Welcome to T3 Day 23 of Calculus. Today we are going to continue our discussion of integration by W substitution. Remember, what we're searching for are pieces that are linked by a difference of 1 power. So look on the inside here, we see x squared minus 4, and then on the outside you see 3x, but the difference in power is 1. So you reduce the power by 1 to get from there to there. That's a good sign that U substitution, I say U substitution, but we can call it W substitution, that's fine, will work. It's not a guarantee, but it's a good sign. So what we're going to do is we're going to say W is equal to x squared minus 4. You take it, you let it equal the higher power, and dW will be 2x dx. So dx will be dW over 2x, and then you plug it in, and you're doing the integral of 3x times, well, now it's just w to the 7 over 2 power, and instead of dx, we're going to write dw over 2x. And that magical thing happens that's really helpful is we get rid of that x. It cancels. If it didn't cancel, we'd have a problem because we have multiple variables. We only want one. You can factor out this 3, and you end up with 3 times the integral of w to the 7 halves. Oh, and you can take that 2 out too. So it's 3 over 2, w to the 7 halves dw. And all you do now is you integrate. So you have 3 halves on the outside, that's along for the ride, and it's going to be w. What's 1 higher than 7 halves? Well, that's 9 halves. And what do you have to put out front to cancel the 9 halves when it drops to the front? Well, that's 2/9. And it's going to be plus c. So you can simplify this a little bit. These cancel, and that turns into 1 over 3. So you end up with 1/3 w to the 9 halves plus c. But what does w equal? X squared minus 4. So it's 1/3 x squared minus 4 to the 9 halves plus c. And the way you would test this to see if it's the proper answer is you take the derivative and see if it comes out to this. It should. It will. So over here you see something similar. The power underneath the radical is 1. And the power of x up here is actually 0 because it's x to the 0 if you wanted to put it in there. So it's a good sign that W substitution will work with W equals 2x minus 8. When you do dW, you end up with 2 dx. So dx is equal to dW over 2. Let's do the substitution. It's going to be 4 over the square root of w times, instead of dx, we write dW over 2. We can factor out the 4 over 2. When you pull those out, you end up with 2, it's 4 over 2, so it's just 2, 1 over the square root of w dw. Rewriting that in exponential form, it's w to the negative 1/2 dw. So when we integrate that, we end up with 2 times the integral of, well, excuse me, the integral goes away. Go up 1 power to the 1/2. What do you need out front to cancel 1/2? Well, you need a 2 over 1 plus c. So what will that come out to be? 4 w to the 1/2 plus c. What does w equal? 2x minus 8. So this is going to be 4 times 2x minus 8 to the 1/2 plus c. You need that plus c. So on this one, we're on W substitution mode. Let's just check to see if there's that gap of a power. Well, this power is 1 for x, and that's 3, so we don't really have it there. But what is this? What is this thing? This just is a polynomial. This is a polynomial, and you know what? If we multiply this out, it's just going to be something that we can integrate straight out. So let's multiply it out. I'm going to write it out like that, and then do the next multiplication piece by piece, multiplying these two. So you get 4 minus 2x plus x squared. I'm going to simplify a little bit inside the parentheses, so it's 4 minus 4x plus x squared dx. And now I'm going to multiply in the x, oh, it's cubed, sorry. So you end up with 4x cubed minus 4x to the 4th plus x to the 5th dx. Now this you don't need substitution for. So just because you have W substitution doesn't mean you have to use it every time. If you integrate this, it's just going to be x to the 4th minus 4 over 5 x to the 5th plus 1 over 6 x to the 6th plus c. So if you can make something into a polynomial quite easily, go ahead and do it. Pretty straightforward. So on this one, there isn't a polynomial, but you have sine and cosine. So the derivative of sine is cosine. So let's let w equal sine of x. And keep in mind, sine to the 5th x, that's the same as, that is the shorthand for sine of x all to the 5th power, the whole thing. Just as a side note, please remember that. So if we do this substitution right here, we'll do the derivative first. dw would therefore be cosine of x dx, because the derivative of sine is cosine. So dx is equal to dw over cosine x. So let's do the substitution. So it's going to be w to the 5th times cosine x, but instead of dx, we write dw over cosine x. And does something really nice happen? Yeah, the cosines cancel. We love that because it gets us down to one variable, which is w to the 5th dw, which we can integrate to be 1/6 w to the 6th plus c. But what does w equal? Sine. So our final answer would be 1/6 sine of x to the 6th power plus c, which you could write a little differently as 1/6 sine to the 6x plus c. It's just a little clearer that way. There you go. So if we move on to tangent, what do we do for tangent? We have to be really careful here. Well, let's use W substitution, but we need to rewrite tangent into something we can do a substitution into. Tangent is sine of x over cosine x. And it's going to be like this. So these are the same, just rewriting tangent. Let's let, in this case, W equal cosine x and see what happens. Or we could let W equal to sine x and see what happens. But let's just try W equals cosine x. dw is going to be equal to negative sine of x dx. So dx is equal to negative dw over sine of x. Let's do that substitution and we end up with sine of x over w times, instead of dx, we have negative dw over sine of x. What happens here? The sine x is canceled, which is awesome, and we have this negative to factor out. So we have the integral of 1 over w dw. So that's the integral of w to the negative 1 dw. And we know the integral of w to the negative 1 is going to be ln of the absolute value of w. And there's a negative outside because of right like that. That's plus c. But what does w equal? Cosine. So you end up with negative ln of the absolute value of cosine x plus c. Just like that. Woohoo. There it is. You could try doing it with w equals sine x and see what happens. So this one, W substitution can be used, but picking the right W is a little tricky. So let's try one and see what happens here. I'm just going to pick the whole numerator. You can pick whole things and see what happens. E to the x is pretty cool because the derivative of e to the x is e to the x. So let's say W is equal to e to the x minus e to the negative x. What does that mean dw is going to be equal to? Well, that's going to be e to the x dx minus the integral of the derivative of that. So let's see what happens here. If we do the derivative of this, you end up with minus e to the negative x times negative 1 dx. Because of the chain rule, that negative sign goes right there. So what do we end up with? dw is equal to e to the x dx plus e to the negative x dx. So dw, what we can factor out of dx, is e to the x plus e to the negative x. So dx is equal to dw over e to the x plus e to the negative x, like that. Let's plug that in right there, and what do we end up with? We end up with the integral of, well, this thing is what we put there, so that's w over e to the x plus e to the negative x times, and what is this dw? dx turns into this, so it's dw over e to the x plus e to the negative x. The problem is these don't cancel. They're in the wrong place, but we're really close, aren't we? So let's try this the other way. Instead of substituting for the numerator, let's substitute for the denominator. So instead, let's let w equal the denominator, e to the x plus e to the negative x. Similarly, dw is going to be e to the x dx, and this derivative there is going to be negative e to the negative x dx. We can factor out the dx's, so we get e to the x minus e to the negative x. So dx will be dw over e to the x minus e to the negative x. Let's do the substitution. Now this right here was w, so that means we're going to have the same thing up above, but on the bottom we're going to have w, and then instead of dx we're going to have this thing that we have right here. So dw over e to the x minus e to the negative x. Well, look what happens. This is the same as this, so what happens? The whole thing cancels. And you're left with the integral of 1 over w dw, which is the integral of w to the negative 1 dw. And you know that the integral of w to the negative 1 is ln of the absolute value of w. And w is this. So you plug it in, and you end up with ln of the absolute value of e to the x plus e to the negative x plus c. So sometimes it takes a couple tries. We were really close before, but that helped us see that you just do the numerator instead of the denominator instead of the numerator. Okay, let's practice one more. Well, there's a good sign here. The power there is 3, and the power here is 2. So that's a good sign. We want it to go down by 1 like that. So w is equal to x cubed plus 2. dw is going to be equal to 3x squared dx. So dx is equal to 3x squared, sorry, dw over 3x squared. And now we do the substitution. So we have 3x squared on top over the square root of w, but instead of dx we write dw over 3x squared, and look what cancels. That's kind of nice. So we ended up with 1 over the square root of w dw. Convert that to exponential form, it's w to the negative 1/2 dw. And when you integrate that, you know it's going to be w, what's 1 greater than negative 1/2? Well, that's positive 1/2. What cancels with 1/2 to get 1? Well, that's going to be 2 over 1 plus c. So with 2w to the 1/2 plus c, and we know w is equal to x cubed plus 2. So 2 times x cubed plus 2 to the 1/2 plus c, which you could write as 2 times the square root of x cubed plus 2 plus c. These are the same, so either one is fine. So look for instances where the power differs by 1, or you can link together sine and cosine, for example. But choose your substitution wisely. Sometimes you might have to do it a couple times.